video, we are going to see sensor interface. So first, let's see what is analog sensor and what is digital sensor. So an analog sensor measures a continuous physical quantity such as temperature or pressure and produces an output signal that is proportional to the input. And the output signal is typically a voltage or current that varies continuously with the input. For examples of analog sensors like thermocouples, pressure sensors, etc. And if you are taking digital sensor, a digital sensor produces an output signal that is in the form of discrete values or digits, usually in binary code. Digital sensors typically use an ADC converter to convert the analog input signal into a digital output signal. For examples of digital sensors like optical encoders, proximity sensors and temperature sensors, etc. So the choice between analog and digital sensors depend on the application requirements. So analog sensors are often preferred for applications where precise measurement of a continuous physical quantity is required, like this, such as in temperature or pressure sensing. So digital sensors are often preferred for applications where discrete or binary data is required, such as in position sensing or motion detection, like. So now we are going to see smart street light using IR and LDR sensor with ESP8266. So most of the places have automatic street light which can sense the daytime and nighttime and automatically turns on and off according to the day and night, right? So here we are extending this by adding one more constraint to turn on the light. That is, street light will only glow. If there is darkness and someone is passing through the street, so the main object of this to reduce the power consumption just by glowing the street light only when it is needed. Here we are demonstrating the prototype of the smart street light with one IR sensor, one LDR sensor and two LEDs. One is for IR and one is for LDR. So now let's talk about the sensors. First is IR sensor. So it is an electronic device which is used to detect objects by sensing infrared radiations which is reflected from the objects. It mainly consists of a transmitter IR LED and a receiver photodiode. It detects infrared radiations which have wavelength from 700 nanometer to 1 millimeter. So when a specific positive voltage is applied across the transmitter LED, it transmits the IR rays. If these rays falls on some object, then the object reflects back the IR rays which are received by the receiver photodiode. So the receiver diode generates a voltage across its terminal which depends on the intensity of light reflected on the object. So generally IR sensor LED is darker, which is black, whereas transmitter is transparent in color. And then so again I am telling you this valuable information. You can convert this masterclass into internship. So let me tell you what are the benefits you will get in this internship, right? So in this internship you will get 30 days of live recording sessions. You can get access to all the records. You will get 8+ project source code. You can join the VIP community group. You can download all the presentations. You will get internship confirmation letter and after that you will get internship certificate. So the actual amount of this internship is for 1,999, but there is a discount amount which is available for you which is only for 799. So this is the registration link. Go for it and make your registration. And the last date to register is 5/6/2024. Make use of it. And these are the ads-on project you will get in this internship, which are smart street light using LDR and IR sensor, monitoring soil moisturization using sensor, gas leakage detection using Arduino IoT cloud, an IoT based heartbeat monitoring system,
and BME 280 sensor readings to the real-time database, web-based remote serial monitor, sending email using SMTP and telegram request to the sensor readings. And also there is a 3-in-1 bundle course is available for you. In the lineup you will get IOT, embedded system and Arduino. And the registration actual fees is 1,999, but there is a discount amount which is available for you, which is only for 999. So this is the registration link. Go and grab it, and the last day to register is 5/6/2024. So make use of it. And what are the benefits you will get in this bundle course? You will get 90 days of live session, 1 year validity, 20 plus project source code, and you can get access to the VIP community group, and you can download all the presentations. You will get internship confirmation letter and internship certification.
LDR sensor. So LDR sensor stands for light dependent resistor, also known as photoresistor. So it is sensitive to light and its resistance change according to the intensity of light falling on it. It is made up of high resistance semiconductor and its resistance increases in darkness and decreases in light. When light incident on the LDR exceeds some threshold, it absorbs the photons and allows electrons to jump into the conduction band. So LDR generates a variable resistance which depends on the intensity of light falling on it. It is mainly used in electric circuits like smart light, alarm clock, automatic brightness and constant control, etc. So that's all about the sensor. So now let's move to the coding part. Let's write the code for this. So first we have to initialize the pin number. First, let me take LDR. I'm going to define this with D6. And then integer LDR LED. I'm going to take D3 and then integer IR. Let's take D5 and then IR LED. Let's take D2. So that's all about the initializations. And inside void setup, let's start with serial begin. We have to pass baud rate 9600. So now I'm going to mention the pin and its mode. So pin mode, first LDR, which is input, right? And then again pin mode of LDR LED, which is output. And then again pin mode, which is IR, which is also input. And then pin mode of IR LED, which is output. Now let's move to void loop function. First what we have to do is that we have to read data from the sensor and we have to store it in a variable. For that I am going to take LDR value. Here I am going to read. I am going to use digital read. First I am going to read LDR and I am going to store it in a variable called LDR value. Again IR value. Using digital read function, here I am going to read IR sensor. So now we have to make conditions. We have to make 4 conditions. First condition is for, we have to check whether it is night time or not. For that I am going to give if condition. Inside I am going to check LDR value, which is equal to 1, which means night time. Our LDR sensor resistance will be high on night time, right? So I am going to check whether it is 1. If it is 1 in the sense, inside I am going to check before that we have to make digital write. So inside I am going to make my LDR LED high. So let me write the command here also. Here I am going to give like night time. So if this condition is true, in the sense our particular LDR LED will be on high state. So now I am going to make another condition for vehicle detection. So if IR value which is equal to 0, in the sense, so inside I am going to make digital write of IR LED high, and also I am going to print like it's night time and vehicle detector, and then let's give a delay like 1 second. So if IR value which is equal to 0 here, which means vehicle is detected, then LED has to be high, and then it has to print the message like it's night time and vehicle detector, and I am ending with delay. So now another condition. Now this condition is for no vehicle detection during night time. So same, if LDR value which is equal to 1, then inside digital write I am going to make LDR LED high. During night time our LED has to become high, and then I am going to check for vehicle detection. So IR value which is equal to, now it's 1. Digital write, inside I am going to make IR LED as low. So no vehicle detection time, in the sense our LED has to be in low state. Now we have to print a message like it's night time and no vehicle detection. So now let's give a delay of 1 second. So now we have to make conditions for daytime. So for that we have to check if LDR value which is equal to 0. If daytime, in the sense I have to make my LDR LED low, right? Okay. Now we have to check vehicle detection. So IR value which is equal to 0, no vehicle detection. Now here vehicle detection, in the sense digital, we have to make write, right? Digital write IR LED is to be high during vehicle detection. And serial println, here we have to print it's daytime and vehicle detection, like detector. Now we have to make a delay of 1 second. So let me comment it here like daytime. Now another condition for no vehicle detection. So if LDR value which is equal to 1, during daytime my LED has to become low. So digital write LDR LED has to become low. Now no vehicle detection. So if IR value which is equal to 1, then digital write of IR LED has to become low. Now we have to print like serial println its daytime and no vehicle detected. Delay I am going to give 1000. So that's all. Now let's move to the hardware part. Here have taken IR sensor, here our LDR sensor, here LDR sensor's LED and IR sensor LED. Let's make the connection. So first, IR sensor LED, I am going to connect this with ground. Let's make ground common. So here I am going to connect the negative side with the ground. Here also I am going to take this negative side and the positive side of IR sensor has to be connected with D2, right? So the D2 pin is for IR LED and here LDR LED positive side has to be connected with D3. Now here the positive side of the positive pin of the LDR sensor has to be connected with 3.3 volt. And then we have to the ground. Okay. And then the D out pin has to be connected with D6. Now IR sensor. The first is output pin. You have to connect it with D5 and the second pin is ground pin. You can connect it here. And the VCC pin has to be connected with 3 volt. Okay. So now let's upload the code. So here the LDR sensor is used to detect whether it is daytime or night time. Here we are using LDR sensor module. So positive side is connected to 3.3 volt and negative side is connected to ground. And it has both analog and digital output. But here we are using only digital output pin. So the output pin is connected to the D6 pin of ESP8266. Then IR sensor are used to detect if someone is crossing on the street or not. It detects the obstacle or motion in the surrounding. So the transmitter will transmit IR rays which will be reflected back if it falls on some object like person, animals or vehicles, etc. The reflected rays will be received by receiver diode and hence will confirm the presence of object and corresponding LED will be glowed. This method will save significant amount of electricity as the street light will only turns on if there someone is present in the street. So it's uploading. Let's wait for a few seconds. Yeah, now let me open the serial monitor. Here you can see the output. So it's daytime. I spelled wrong here. It's daytime and vehicle detector. And it's night time, no vehicle detector. And it's night time. Vehicle detector. Daytime, vehicle detector. Nighttime, vehicle detector. Nighttime, no vehicle detector. Our LED has become high according to this. So this is our output.
Yeah. So again, I'm telling you this valuable information. You can convert this masterclass into internship. So let me tell you what are the benefits you will get in this internship, right? So in this internship, you will get 30 days of live recording sessions. You can get access to all the records. You will get 8+ project source code. You can join the VIP community group. You can download all the presentations. You will get internship confirmation letter, and after that you will get internship certificate. So the actual amount of this internship is for 1,999, but there is a discount amount which is available for you, which is only for 799. So this is the registration link. Go for it and make your registration, and the last date to register is 5/6/2024. Make use of it. And these are the ads-on project you will get in this internship, which are smart street light using LDR and IR sensor, monitoring soil moisturization using sensor, gas leakage detection using Arduino IoT cloud, and IoT based heartbeat monitoring system, and BME 280 sensor readings to the real-time database, web-based remote serial monitor, sending email using SMTP, and telegram request to the sensor readings. And also there is a 3-in-1 bundle course is available for you. In the lineup you will get IoT, embedded system and Arduino. And the registration actual fees is 1,999, but there is a discount amount which is available for you, which is only for 999. So this is the registration link. Go and grab it, and the last day to register is 5/6/2024. So make use of it. And what are the benefits you will get in this bundle course? You will get 90 days of live session, 1 year validity, 20+ project source code, and you can get access to the VIP community group, and you can download all the presentations. You will get internship confirmation letter and internship certification.